Welcome to the poster sessions. In this poster, we are talking about silicon bug hunt using the deep sea phishing methodology. We have worked with a lot of companies to use a form verification to verify their design. And to be successful with form verification, user a lot of time need to deal with a lot of success factors, such as the complexity of the design, the quality of the assertions in the design. A lot of time, the assertion need to be rewritten to be formal friendly, and the completeness of the interface or the constraint used for the interface. So if a standard protocol is used for the interface, then a standard monitor can be used to constrain the interface. Today's formal tool has a lot of formal engines. The control and the orchestration of the formal engines is important to get the best result. The initial state for formal verification is very important. You want to start from an initial state where the design has been initialized correctly. And there's always help to have formal expertise in the team. As a silicon bug hunt is probably one of the most difficult usage of formal verification, we have developed a radar chart to guide the deployments of formal verification to find deep silicon bugs. Divide the bug hunt process into three different phases. Phase 1 is the initial phase. It's marked by red in the diagram. So in this phase, we gather all the information. We set up the formal verification environments. We want to make sure that we have everything in place. So phase 2 is the improve phase. So in this phase, this is marked by green in the diagram. We want to improve each of the success factor. So we look success factor is the most critical. So for example, if we do not have an expert in our team, we may want to find an expert to help us to deploy the process. We want to develop the assertion to capture the bug. So we want to write assertion to capture the P conditions, the bug scenarios, and also a potential sequence of events that lead up. Okay, let us take a look at how we use this methodology to find one of the silicon bugs in this DDR3 controller. So the problem is related to a sequence of write command to a specific memory bank in the design that cause a P charge timing protocol violations. For the complexity of the design, we know the controller that caused the problem. So it has an AXI interface, so we can use an AXI assertion monitor to constrain the interface. To make sure that the formal run is as efficient as possible, we have turned the memories and unnecessary part of the design into red boxes. And we have also done a number of plenary runs to make sure that formal verification has sufficient control of the design. The quality of the assertion is very important. The assertions are written to capture the bug scenario and also the sequence of events that lead up to the bug. But this is important because by using a sequence of assertion as sub-goals, we are able to deploy to recreate the sequence of events in formal verifications that help guide formal verification to target the bug scenario specifically. Initial state, the serial nature of the design make it very challenging to apply formal verification directly. But we are fortunate in this case because in the design there is an init OK signal that can be used to tell formal verification that initialization has been done. All these informations, we have set up the initial formal run. So that is being marked in red in the diagrams. Now keep in mind that the design has actually 5 AXI interfaces. So in our initial formal run, we have disabled 4 AXI interfaces. We want formal to focusing on one of the AXI interface exclusively. Second phase, we continue to improve each of the success factors. So we are using a black box a little bit more. We're also creating a cut point for the design. Goal posting, when formal verification has hit a sub-goal, we are using that sub-goal as an initial state to guide formal verification towards the assertions. So that has helped improve the efficiency of formal verifications. So instead of starting from time 0, we are starting from a much more meaningful initial state. So in the final phase, formal verification was able to hit the bug scenario. However, as we observe it carefully, we find it different from the bug scenario happen in silicon. So we add additional constraint to make sure that we are finding exactly the scenario as in silicons. So later on, we relax the constraint to uncover other scenario that will lead to the bug. Actually, there are multiple scenarios that will lead to the bug, so we have to fix each of the scenario carefully. So using this methodology, we have done a number of bug hunts, and another one is related to a memory controller. We have gone through the similar process, phase 1, phase 2, and phase 3. We continuously refine each of the success factor and define the bug. but we don't have time to go through it in detail. So if you're interested, please send me an email and I can send you the white paper that describes the process in detail. So thank you very much for attending the session. So please feel free to contact us if you have any questions or interest to know more about the methodology.